Okay, now we're going to talk some more about continuous functions. First off, if we have two functions, f and g, that are continuous at a point C, then the following combinations are also continuous at that point C. Their sums, differences, constant multiples, products, quotients, powers, and roots are all also continuous at C. If we have composite functions, if f is continuous at C and g is continuous at f of C, then the composite g of f is continuous at C. Now you can look at this graph and see that it appears to be continuous. If you look at the actual formula for this graph, since it's made up of products, quotients, sums, composite functions, and x is continuous, sine of x is continuous, x squared plus 2 is continuous, the absolute value of x is continuous, then by using all those rules we can see that this graph also should be continuous. Now, the limits of continuous functions. If the limit as x approaches c of g of f of x is g of b, then it's also going to be equal to g of the limit as x approaches c of f of x. What that tells us is if we have the limit of a composite function as we have here, we can find that limit by doing, the cosine of the limit as x approaches pi over 2 of 2x plus the limit as x approaches pi over 2 of the sine of 3 pi over 2 plus x. So that would be the cosine of. Now when we find these limits, we substitute pi over 2 in, so this is going to be 2 times pi over 2 plus the sine of 3 pi over 2 plus pi over 2. Well, this will give us the cosine of, the 2's cancel, we'll have pi plus the sine of 3 pi over 2 plus pi over 2 is 4 pi over 2, or 2 pi. Well, this is going to be the cosine of pi plus, well, the sine of 2 pi is 0, so this is the cosine of pi, which is -1. So if we have a composite function, we can just look at this as plugging in the pi over 2 in each spot. Now the last thing in this section is the intermediate value theorem for continuous functions. The intermediate value theorem says if f is a continuous function on an interval from a to b, closed interval, and y sub 0 is any value between f of a and f of b, then y sub 0 is equal to f of c for some c in the interval from a to b. What that says is if this is a continuous function from a to b, then any y value between f of a and f of b must have some value c between a and b for which f of c is equal to that y value. In other words, in order for this function to go from f of a to f of b, it must pass through every y value in between f of a and f of b to reach from one to the other. And that y value must occur between a and b. Now it only holds for continuous functions. This is a discontinuous function. It's discontinuous at 2. So the intermediate value theorem does not hold. Notice that there is a spread of numbers here between 2 and 3 that where there is no y value. It's because this function is discontinuous. If it had been continuous between 1 and 4, then it would have had to cross through every y value between 0 and 3. But since it's discontinuous, it did not cross through every y value between 0 and 3. Now one place that we see the intermediate value theorem applied is in finding roots of functions. Here we see the function f of x equals x cubed minus x minus 1. Now, most of you have probably found zeros of functions like this using the TI-83 or TI-84 calculator. When you did that, you used second and trace in the calculate menu, and there is a function there for finding zeros or roots. Most calculators call it zero. Occasionally a calculator will call it roots. And it always asks you to find a left bound and a right bound. And the way this works is if I have a function that's continuous, say from here from 1 to 2. And at f of 1, I have -1 here. And at f of 2, I have 5. In order for this function to go from -1 to 5, it must cross through every value between -1 and 5, including 0. And when it asks you to find the left and right-hand bound, what you're doing is you're finding a number that's a negative number and a number that's a positive number. So we know that this function must have a 0 in between 1 and 2, since f of 1 is -1 and f of 2 is 5. Similarly, you can see here's 1.5, that it has a positive value. That 0 must be somewhere between 1 and 1.5, since f of 1 is negative and f of 1.5 is positive. Now you can continue to apply this. We could look at 1.25. And at 1.25 we have a negative value, and at 1.5 we have a positive value. So we know our 0 is somewhere between 1.25 and 1.5. The decimal approximation is actually 1.32. But if you kept zooming in, you could find that that 0 is somewhere between 1.3 and 1.4. 1.4 is positive. And